about Neo4j and building Java applications with that, kind of what that entails, what that looks like, and a little bit of background on Graph, in case you're not familiar with that. My name's Reif. I'm a developer and advocate at Neo4j, and I enjoy learning technology, which is a good thing for this field. And then I like sharing what I've learned. So whether that's through content writing, blog posts, videos, speaking at conferences or virtual events or wherever, I'm happy to do all of that. And then I have some hobbies outside of work, but most of those just boil down to the fact that I'm kind of a geek. So that's okay with me. Contact information is there. So if you think of something later on down the road, after the conference ends, months down the road, whatever, feel free to reach out to me. I'm more than happy to answer questions, talk tech, Neo4j, any of that stuff. So I'm more than happy to do that. Sometimes our best questions end up long after you've kind of lost that contact. So, all right, so let's talk a little bit about what is Graph, what that looks like. First off, it is actually a database. It's a data storage. There are some kind of graph technologies out there that are tools or visualizations or layers on top of data. But in the case of Neo4j and several other vendors out there, they're actually a database, which means they store the data in a physical storage location of some sort, and then we store those relationships with the entities themselves. So this is super powerful when you start querying. So you're getting the results based on the network structure, so the graph, the entities, and the relationships. It's also really powerful when you visualize it. You can comprehend the depth of your network, how big it actually is and how connected.
And it's really powerful when you utilize that in algorithms and pipelines. So you're factoring in the network into those calculations. So based on my network structure, can I deduce what decisions a customer might make or someone might make? And can I factor those into a flat number that then I can put into like machine learning pipelines or other types of calculations. So all of this type of structure, not only are you taking details of the entity itself into account, you're also taking into account their network structure and the connections that they have in the system. So a little bit of history on graphs. It's actually much older than the technology. The technology was founded somewhere around 10 years ago. But it's actually based on graph theory, which the foundations of that was formed back in the 1700s by a scientist named Leonard Euler. And they were trying to solve this puzzle. They had 4 landmasses and 7 bridges that connected the city of Königsberg, Prussia at the time. And they were trying to figure out, can I go from point A? Can I cross all 7 bridges? Can I come back to my starting point without repeating paths? And actually that solution is not possible. However, the math that was formed behind it, the solution to that problem was the foundation for graph theory. So you can kind of see as it progressed, you have the actual map and the city structure, and then you actually get the graph theory. You have 4 endpoints, 4 land masses, and you have the connections or the bridges that go between them. So just as it was then, graph theory kind of arose from trying to solve a puzzle. Indeed, the graph database itself arose from the current solutions or the current databases not filling the problem that somebody was looking to solve, right? So technology that they had at the time, super complicated for the problem they were looking for, business problem they were trying to solve. And so a developer said, I'll just build my own. And so that's where graph database first came into being. So let's talk a little bit about the data model. How is the data structured? What does that look like before we start diving into the application side of things? So property graph, which is what Neo4j and a few other graph database vendors are founded upon, focus on nodes and relationships. If you're familiar with the mathematical or graph theory terms, those are vertex and edge terms. But basically you're dealing with these 2 main components. You have the entities themselves and then the connections or relationships between them. So nodes represent your objects or your entities in your data domain. You can label them, kind of like grouping them into kind of categories, if you will. So here we have a couple of nodes that are categorized as the Java versions, and then you might have some diffs between those. And then you can also add properties, so metadata on your nodes. You can see kind of some examples. We have, the version and maybe when the version went GA. A version diff, you might compare 2 specific subversions of that, etc. Then you have relationships. You have to have some sort of type for your relationship. It's kind of like a relationship label, if you will. It helps categorize what the quality of the relationship is between two entities, and you also need a direction. After all, you can't really tell maybe an entity is a parent and a child. You can't really tell which one might be parent or child unless you have that direction specified, which helps you better understand that domain. You can also add properties to relationships. So here we might say, we have a Java version going to another Java version. What would I do to migrate those? It's going to take 3 steps to migrate between these 2 versions. And you might compare, okay, is there any faster upgrade path between version X or Y or A or C or et cetera? And then nodes can actually share multiple relationships as well. So depending on, again, your data domain and kind of what you're looking to do, you might have more than one relationship passing between nodes. Again, helping you better understand the connections and the relationships in the actual data itself in the real world. So you can have different types of relationships. Again, that kind of helps differentiate based on direction. So a common one we use at Neo4j is you might like someone else, but they might not necessarily like you back. However, if you're friends on Facebook, if you friend someone on Facebook, they're automatically friends with you back. Those 2 relationships are totally separate, even though they kind of mean the same thing. But based on that data domain and the context you're dealing with, they could mean totally different things. Okay, so a label is kind of like a group of nodes. It's like a category. Coming from a Java background, you can think of it kind of like a domain class. It's kind of your general definition for that object. You can also have subclasses, if you will, or in this case, additional labels that you could further categorize entities with. So I like to think of this as a Java background. This is kind of like inheritance. So you have a group of nodes that are all person nodes. Then you have some that might be labeled employees, some that might be labeled customers, and you might even have some overlap where you have one person in the middle who's a person and an employee and a customer all at the same time. Again, it helps you better understand, okay, this person I would speak to a little bit differently than I would just a person who's outside my company or outside my customer zone, right? Properties are key value pairs. So this is, in my mind, pretty straightforward as a developer. I think of it like a variable name and value. You can associate these with nodes or relationships, as we've kind of discussed. So properties, again, just key value pairs, and you can kind of link those or attach those to nodes or relationships, depending, again, on that data context. All right, talk a little bit about the modeling aspect of it. Neo4j specifically is known for being whiteboard friendly. And what that means is most of us as developers, when we're faced with a new data domain or even existing one that we might want to make changes to, we often will go to the whiteboard or a piece of paper and we'll draw it out, right? Well, the data domain that you would draw on the whiteboard is actually what is going to get put into Neo4j. It's what's going to get stored. So you can see that what I end up with in the final result inside the database is actually, in this case, exactly the same as what I drew on the whiteboard. So I did this kind of exercise, went to the whiteboard, drew out my Java version domain, and then I actually imported it into the database, and that's the model I got when I put it in there. So again, the data is modeled very naturally to how it exists in that real world, making less of a translation between the format the data is getting stored in and the actual data as it exists in the real world. All right, so now we're going to switch gears a little bit and talk about developing applications with Graph. What would I need as a developer coming into this? Am I having to retool? Am I having to do a lot of different thinking, et cetera? So right now, if you're a Java application developer, your data store options, again, relational's been around for a long time, so there's lots of options here, right? You've got JDBC, you have JDBC template, you have tools like Juke, JPA or Hibernate mappings, and so on. If you're dealing with NoSQL, there's a wide variety of things there, but focusing in on document databases, kind of the go-to is probably MongoDB. And when you're looking at Graph, most of the time your go-to is probably going to be Neo4j. It's the one that's been out there the longest, at least. Other types of options, but Neo4j has quite a few integrations. So that's kind of the go-to mentality there if you're dealing with Graph. So as a Java developer, why would I choose Graph? I've got all these options with relational. I'm already familiar with them. Why would I switch and do something new? First off is Graph's going to help you answer complex data questions. So for instance, we have Java versions, and we've got diffs that go between them. So the changes or the deltas between the Java language versions. So I started out at, let's say, Java 17, and I want to look at maybe migrating to Java 18 or even the brand new Java 19. what would all that involve? What are the diffs? What are the new features? What are the methods that have changed or the classes that I need to upgrade in my applications, etc. So really comparing the tree there, if you will, of all the changes that goes into that. So if I want to look at now, not necessarily at changes between two specific versions, but maybe over time. Let's say, okay, I want to look at Java 8 and 11. What are all the things that have changed within there? What are some things that have been added to the language since those versions? And features and methods and classes, what are the diffs between those? So again, looking at that very deep tree, then at that point, maybe 6 hops down for everything that's changed over a long period of time, perhaps. Or I might even want to pick a particular feature in the Java language. So what about date time? How would I do date time back in Java 3 versus Java 6 versus Java 14? And so you can look at one specific feature, dive into that, and then look up and down the tree to figure out what all has changed, or what's new, or what it looks like now. So again, very complex data questions, things that you can absolutely do in other databases, but it might not be as simple or as straightforward as what you would find in Graph. The other thing is aligning your domain with your application domain. So your data domain in the database and your application domain. In Java, most of us are probably familiar. We have classes for your entity and objects. It's the general outline for objects of that type, right? It's not necessarily a single instance. It's just kind of a general outline for anything that falls within that. You have variables and properties, which are your details. You can have values that may not necessarily exist. You could have empty or null values in there. And then your constructor is typically your instance of that object. So each instance is going to be unique. This looks really similar to the way that graphs categorize entities and the domain as well. You have your nodes, you have kind of labels that categorize groups of those nodes, you have individual nodes, kind of like the constructor instances of that, you have variables and properties that give that metadata that are paired in kind of key value pairs, if you will. And again, that aligns really, really well with already the way we're thinking of the domain in Java. We also get relationships. Now, this you're not doing a whole lot of coding differently. If you look at the example I have on the right-hand side there, we've got an annotation. We've got a domain variable there that we're assigning. The difference here is going to be that relationship you're assigning is not just in memory. You're not calculating that based on a key or a lookup value in a database. You're actually going across that physical relationship in the data store itself. So you are still mapping that, but that mapping is actually physical on the database side. You're just reading it. So that's one difference, even though it looks pretty much the same as what you naturally probably already do in Java. The data storage layer underneath looks a little different. So I won't read all of these, but this is kind of just the general outline of if you're looking at a relational database background versus a graph database, you're dealing with set theory on the relational side, you're dealing with graph theory, which is a network structure on the graph side. Schema is going to be much more strict and enforced on the relational side for good reason, where the graph database is designed to be much more flexible and optional on the schema side of things. The biggest thing is going to be further on down where we talk about the relationships and the queries. Your relational database, you're going to craft those joins into the data format. So you're going to add those foreign keys, or you're going to add those potential values so that you can do joins at runtime when you actually run the queries. In a graph database, your relationships, you're storing those with the data itself, and so you're doing the joins at write, but that means you're reading stuff that's already there naturally in the data. You're not crafting that yourself. I also kind of like the imagery here. So on the left-hand side, it's kind of like going, okay, I need a coat and boots for the next stop, for the next destination, but then I'm headed to the beach, so I'm going to need my swimsuit and sunscreen. And so then you would have to pop back home, basically like a lookup, pop back home to get the things that you need for the next hop. So that's kind of the way I like to think of relational databases and structure. You're kind of going back to home base to pick up the things you need for the next hop. Where in a graph, the things you need for that next hop are at the next location. So I take one hop and I already have my boots and my coat waiting for me there to help me get on to my next destination, which has my swimming suit and my sunscreen for the next hop and so on. So you're taking the things that you need are at that next destination. So hop to hop versus coming back to home base. Okay, so a little bit about the demo, and then we'll dive right into the core of stuff, but just to kind of give you an idea of what we're covering and the data we're looking at. So I created a Neo4j AuraDB free tier instance, which everybody can do. I'll have a link at the end for anybody who's interested in doing that. So you can spin up your own free instance. It's a cloud database as a service. And we have options for paid tiers as well, but we have free instances for those who just want to test out the product or toss in some of their own data to play with, proof of concept build, and so on. And then I loaded the Java language version data. I've got links to where this data is and how you can pull it in. It's open source. It's a GitHub project. There's a website and everything that they pull from, and I've just basically loaded that into my graph database. So I showed a larger version of the data model earlier, but we're going to focus really in on the Java versions itself, so 8 versus 11 and so on, and then the diffs between those. So calculating this basically just has the properties for, I have a from version 17, or a to version, excuse me, of 17, and then comparing that to 11 here in this case. We're going to use the Neo4j Java driver, which is an official driver provided by Neo4j. However, there are plenty of other options if you're not a Java person. So we have several official drivers that I've listed down there in blue, and then we also have many more community drivers, either provided by partners or customers or even just community hobbyists that have written their own drivers to go along with that. And then we're using Spring Data Neo4j, which does use the Neo4j Java driver at the base. However, if you're not a Spring person, we do have support for other Java frameworks, things like Quarkus, Helidon, Micronaut, and many more. We also do have a lot of integration. So if you're already dealing with certain tools or databases or other sorts of things, there's ways to integrate your data, move it back and forth, or do extra visualization layers or tools and so on. So plenty of options there, even if these things aren't your cup of tea that we're going to use today. All right, so the reason I chose Spring, mostly today, I won't focus in on all of these, but it reduces a lot of boilerplate. So for demos, that's really nice. A lot of things are provided via annotations, so really simple mapping stuff. And I can write queries in the basically kind of native query language that the database is used to. So for instance, if I were dealing with Mongo, I could write JPQL, which is Java Persistence Query Language. If I were writing for relational databases, I could write SQL. With Neo4j, I get to write Cypher, but then of course Spring provides some query derivations, some things that are naturally derived from your syntax that it'll kind of write some general queries itself for you, but that you can always customize, of course. So really nice things about Spring, helps kind of shortcut some things for today's demo, but that's kind of the reasoning behind that. All right, let's dive in and actually look at some code. So what I'm going to do is switch over to my browser. And this is the console for the database, but I'm actually going to go to the Spring Initializer, which is just where I can kind of pump in some dependencies and so on, and it will kind of build the project framework for me, the template, if you will. So I'm gonna leave it as a Maven project in Java, because that's what we're focusing on today. Latest stable version of Spring Boot. The group name I just changed for categorization of my projects. And we're going to call this Jconf demo. Jar packaging's good. Java 17 is fine for now. And then I'm going to choose the web dependency. That's going to allow me to create a REST API. So we can hit endpoints and be able to connect to our data. I'm also going to tack in Lombok. Some people are fans of that, some people are not. But it's going to shortcut some things so I don't have to write getters and setters and so on. And then Neo4j, of course, into that so that I can connect to Neo4j. I'm going to generate that project, which will download the general template or skeleton, if you will, of the project. And then if I switch and unzip that and open that in IntelliJ. Come on, conference Wi-Fi. Although that shouldn't be the Wi-Fi, it's local. Come on, you could do it. All right, so I usually like to go in and check while it's trying to sync and just make sure everything looks good. So we've got the Spring Boot version, Java 17, Neo4j dependency, the web dependency for our REST API, Lombok dependency, and then it adds in a starter test dependency and the Maven plugin for us, automatically included, but nothing fancy there. Then inside the resources folder, I'll need to connect to the database. So I'll need some type of credentials here. I can use the URI and the username and password. And then because Neo4j supports, can't type, multi-database, you can actually specify a database name here too. So there are a lot of database management systems out there that support multi-database. Neo4j is one as well. Now, because I am using a cloud database, I don't necessarily want to copy paste my credentials right into this application. So what I'm going to do is I'm actually going to just close that. And inside, I just have a default stuff already ready to go in another file. And so I just need to drop that in. So we're not sharing any secrets here. All right, and then back to IntelliJ. So I just won't open that file now. All right, so we're up to our main application class. And now we can actually start coding our domain. So we have our class of Java version, and then a couple of annotations here. So I want Lombok to create my getters, setters, equals, hashcode, and toString for me, so I don't have to add that extra code for today. So I'm going to use the @data annotation by Lombok. And then I want to specify this as a node in our database. So if you're dealing with Mongo, you would specify @document. If you're dealing with tables in a relational database, you use @entity and @table. So because we're dealing with nodes and relationships inside Neo4j, I can use the @node annotation. Then I need to specify an ID annotation and then my actual ID field. Now, I named this version inside my database, but I didn't want to conflict with the Java keyword version. So I just called it Java version here. So in order to map that to my database property, I can use the @property and say, hey, when you're looking in the database, look for something called version instead. Then I can add my other values here. So I have a Java version, a name. There's a code name for some of them, for the older versions of stuff. I have a status, whether it's end of life or LTS version or in development. And then there's an API spec link out there. And then we also have a couple of my favorite fields is dates for when it went GA and when it went end of life. And so that's all I have to add right now, because again, my getters and setters and everything are taken care of. So now we can add the interface, which is going to be my repository class to interact with the database. And so I can call this Java version repo, and we're going to extend the Neo4j repository. I could use the general CRUD repository if I wanted to, but the Neo4j repository provides a couple extra small things that might be nice. We don't necessarily get into that today, but we'll just go ahead and utilize that. And then we add our controller class. So Java version controller. And then here, it's a REST controller, and I'm going to let Lombok create an all argument constructor for me, so it will kind of do that. And then I need to set up a request mapping for my endpoint, my main endpoint to hit. So I'm going to set that up as /versions. And then first off, I need to inject my repository, so Java version repo, and we're going to call this just repo for now. Again, I don't have to write a constructor because Lombok annotation, all our constructor took care of that for me. So I can get right into my mapping for the methods. So I'm going to have a Java version. We're going to call this find all Java versions. And we're going to return a repo.findAll. Now notice I did not create or define a find all in my repository. This is one of those methods that Spring will derive. Oh, you're looking for find all? My guess is that you want to return everything we can find that connects to the Java version domain entity, right? And so it will kind of auto assume some things there. Again, you can absolutely customize, but we'll just start with the default for now. So we've got that in place. That gives us enough to at least get up and running and see if we can connect to the database and see if it works. So we'll go over here, and if I type in localhost port 8080/versions, then it's really hard to see. You can see we get our Java versions back. Now, you might say, hey, that's great and all, but you're just looking at the entity. You're not going over any relationships. You're not pulling any connections. You're absolutely right. So let's dive in and fix that. We have our main Java version class. Let's add another one called the version diff. And we're going to use the same annotations basically here. So long back annotation, generate our getters and setters. Node to say it's a Neo4j entity in our database. We need an ID field. Now I'm also going to use the generated value here because there really wasn't a good business key here, or a technical key, if you will, to use for this. So I just ended up using kind of the internal Neo4j node ID, which isn't always best practice, but that's what we're going with for now. And then we have a from vendor, from version that we're comparing, and a to vendor, to version that we're comparing. So again, you can see there's not really a great technical key going on there. I would need almost a composite key at that point. So we just didn't do that. Now, again, I haven't specified any relationships. I've just created another entity. We can do a relationship by using the @relationship annotation on the Java version class and specifying the type of relationship we want to follow. Because again, we can have multiple relationships between these two entities. So I want it to follow the from newer relationship. And I want to pull back a list of version diffs that go along with that. And we're going to call this older version diffs, like that, okay? And it's a field, so it maps that. We said we're returning a list of version diffs, so it goes across that relationship to find these entities, and that's all we really should need. So I should be able to just restart this and hop over to here. And while we're waiting for that to spin up, so our initial query where we just looked at Java versions, I can actually look at that in a visual way inside the database itself by doing a query like this. So match, which is kind of like a select or find, Java versions, return the Java version. And so here's the visualization there. You can kind of see some versions. But if you really want to look at what we're seeing, what we returned, then I can do something like this, basically return the map of all the properties. And then you can see we get the full map. Now you'll see there's some extra properties that I didn't include in the Java application, so I could even do something like version dot name dot codename dot, what else did I include? API spec dot GA date and dot EOL date, like that. And then you see actually the results that we saw in our rendition here. So now we can go ahead and refresh this, and we should now get our relationships. So you can see for Java 8, we have older version diffs that we're comparing. So Java 8 compared to Java 1.1, Java 8 compared to 2, compared to 5, compared to 7, and you get the full list. I could go on down here to Java 14, and you see comparing to 10 and 5 and 7, and so on. So now we're pulling across that relationship. We're getting all those entities back. Now I mentioned that you could write custom queries. We're just using kind of the default ingrained one. And so we can write a custom query. We'll basically do the same thing. But inside our interface, we'll just create an @query annotation. And I mentioned that I could use domain-specific language to write those custom queries. So in this case, because I'm dealing with Neo4j, I can write Cypher. So Java version, and then we're going to go across the from newer relationship. Now again, Spring was able to do this because I did a find all, and I have that relationship mapped inside the entities themselves. So call this version diff, and then return the Java version. And then you need to collect the relationships into a list and collect the diffs into a list, because you could have multiple patterns basically that are specified. And then we can say we're going to have multiple Java versions coming back, and we're just going to say find Java versions like that. We're just going to call it that. And so then all I need to do is specify, instead of the find all, I'm just going to create a separate mapping here. We're going to call this /all and define this as Java version. And we're just going to say find Java versions that and return a repo.findJava versions. Okay. So with that, we should be using now our custom query when we go to the /all, and we would be using just the kind of built-in derived find all query if we just go to /versions. So I can do that. I should be able to then just do /all, and I should basically get the same results, right? Because we really haven't changed anything. The derived query is the same. So you see Java 8, we've got all the diffs that connect 8 to 1, to 2, 5, and so on. So again, looks exactly the same as if we were to remove that. And yeah, we see the same data. So again, that custom query is not doing anything differently than the Spring derived query was doing, but you can absolutely write your own custom implementations if you need to tweak or adjust. Now that's good, but there's one more thing I want to showcase. Actually, I'll go back and write the query that we just did. So actually, I can even copy paste the query that I wrote here, pretty much. Oh, come on, sluggish. And paste that in here. Come on. The difference is, if I want to return the visualization, I don't need the collect. So here's the visualization. I know that's really hard to see, so let me zoom in just a bit. Except it's not showing me, maybe because I've zoomed in too much. Yeah, there we go. Okay, so Java 10, Java 7 has fewer connections, fewer relationships, fewer diffs than what Java 10 does, obviously. It makes kind of sense. There's more older versions when you get to the later versions, obviously. So you can kind of see it looks a really neat graph. It's something to kind of explore, something fun you could dive into. Imagine if you were dealing with customers and purchase products or so on. So it could be really valuable there. If we wanted to look at the map version, basically, of what we did, I could do the same thing as what I kind of showed in that last query. So let's flip over and do one more thing. So we have a lot of data coming back maybe in our request. We might want to slim that down a little bit, make it a little bit easier and clearer to see. Maybe we'd want to provide people with a list of all the diffs and not provide a lot of the extra fluff. You can actually write what's called a projection, which is kind of like a view, if you will, using an interface, and we're going to call this Java version projection. And then inside it, we can do a string get Java version. So I'm calling the getter method, which is basically going to grab that Java version property, and then do a list, and I'm going to create a new projection that's going to be get older version diffs, because I want to go across and grab the compared version inside that version diff. So I can then write a nested projection within a projection, and say I want to get from version from that. So what I've basically done is said I'm going to create a view of Java versions. I'm going to call it Java version projection. I'm going to go get the Java version from the Java version entity here. I'm going to pull that back. Then I'm going to create kind of a nested projection, and I want to grab the get older version diffs method, which if you remember right, the older version diffs, I don't have the getter setter there, but it would be there, and it would be called get older version diffs, right? And then within that diff projection, all I'm going to retrieve, I could retrieve the whole diff, what did I call it? Version diff object if I wanted to, but I don't. I really want to just pick out one little piece of that. So I'm going to create another projection that says I want to pull the get from version method from this version diff, so the getter basically for that property, and I'm going to retrieve just that property. So I'm kind of picking and choosing across the relationships in my domain which little bits and pieces I want to get. And that's going to kind of create this new entity called this Java version projection. Now all I need to do is kind of use that as my return type in my methods here. Which of course it's not going to like until I update this. And then we should be good to go. So now when I go to the /all, it'll pull just the projected entity, that view, where if I go fully back to the find all, it's going to pull the full entities that we saw. So let's try that. I'll switch over to browser, and I'll show that inside a Neo4j browser as well, what that would look like. So if I go to the /versions, I should get the same data I always get. But if I add that /all onto the end now, I should get that nice trim, slim version. So I've got Java 8 compared to 1, 2, 5, 7, so on. And I could scroll on down and see, more lists comparing 12 to other language or other versions, etc. So all of that looks good now. We're getting what we wanted to out of that. I could do the same query in the browser as well. So Java version, in fact, I can just copy paste this first bit here. And then retrieve j.version, and I actually can just do collect d.from version like that. And that will collect the list. So I get the Java version and then the list of all the version diffs that it compares to. So that's what it would look like basically in the query. And again, I could write a custom query for that if I wanted to back in the app, but we won't mess with that for today. Okay, so back to slides, and we'll kind of wrap up just a little bit. So resources, all of the source code that I wrote today is in that first repository. Feel free to check it out and try to build it yourself. It should be rebuildable by everybody. Hopefully I've done it correctly. If not, ping me. There's Spring Data and Neo4j documentation. So if you want to find out more about what Spring Data offers, most of their Spring Data projects, whether that's with Mongo or relational databases or so on, kind of provide kind of a standard set of features. There are a few things that Neo4j might provide differently or separately from that. So if you want to check that out, feel free to check out the documentation. The Neo4j Aura DB was the cloud database as a service. Everyone can create their own free instance. Excuse me. It provides some kind of built-in guides to help walk you through initial training and what the data looks like and how to load your own data. It even has some built-in data sets you can try out if you'd like. Or you can choose to load your own as well. My blog, I write Java stuff as well as Java and Neo4j type of content. So if you're interested in that, feel free to check that out. And then last but not least, check out our Nodes event, which is the Neo4j Online Developer Education Summit. That's coming in November. It's a free and totally virtual event. 24 hours, so no matter where you or your colleagues are in the globe, there should be some content out there for everyone. And it covers a variety of things from use cases to projects, hobby projects, what people are doing, Cypher, talking about building applications with various languages, and all sorts of really neat things. So I'm super excited about it. I'll actually be speaking there along with several colleagues and other companies and partners and so on. So really great event. I'm super excited for that. So don't miss that if you're interested. So again, contact information is down there in the lower left. I'm happy to take some questions or stick around for a little bit. But if you think of something later, don't hesitate to reach out to me. Thank you guys so much for coming and enjoy the rest of the event. Yeah.
I come from a traffic engineering background, so we store a lot of spatial data.
Yep.
Different points. For example, like in a node, so
Right.
like interstates connecting different exits and all that stuff. So,
Yeah.
It's graph. I'm new to graph data.
Sure.
So is that some information that can be stored?
Absolutely. Yeah, we have we have some spatial capabilities within the database, but then we also have a spatial plugin that provides a lot of geolocation type of stuff that gets kind of built into that. And then there's several integrations and projects out there where you can superimpose maps and things on top, layers on top of the graph database itself. So there are ways to absolutely store that data in there, and then you can use kind of extra tools and layers if you want to build like mapping or 3D views and that sort of stuff. So it really depends on what you're looking for. But inside the database itself, you can store longitude, latitude, I can't remember the term, WRS and the different geolocation formats of data. And then you can calculate distances and things. There are some functions built into Cypher that do that as well. So some built-in capabilities inside the database itself, and then lots of options for integrations and other layers on top of that too. So.
And then if I wanted to look at like sample stuff, I'm thinking it should be somewhere.
Yes. So Neo4j has a GitHub repository. I think it should be in Neo4j Contrib, if I remember right. Okay. Yeah, there should be plenty of stuff out there, and there's lots of like blog posts and videos and things of people doing spatial stuff. And I think nodes may even have 2 or 3 spatial sessions focused in on that topic area itself. So yeah, I mean, it's definitely a project area that we cover. Yes. Yep. Absolutely. Good question.
And then, so the relationships, like how do you, so from your, right? I mean, that's not something that would be relevant for us, like roles.
Okay.
So it's the from your, like free text. I mean, the relationships are the standard relationships that are there.
No, you define that yourself. Yeah. Yep. So again, it's kind of like a node label. You can set up your own category, or if you want to think of it kind of like a table name, if you will, you can kind of define those and provide that data context inside the data itself. So you get to pick the names and however you want to word it.
Okay.
Yeah.
And so, so we have our existing data in PostgreSpatial and SQL Server Spatial and all that. So,
Sure.
Would there be like a transformer, like, or does Neo4j give you tools that would?
Yes. So we have an ETL tool that will actually just pull data straight from if you have a JDBC connection string, it'll pull straight from that and dump into Neo4j, kind of an initial dump. In the next version of Neo4j, we're actually doing an incremental import tool as well, where you can kind of continue that process and slowly increment if your main storage is still in Postgres. And then we also, if you're dealing with Neo4j Aura, there's a Neo4j importer tool inside Aura that you can take data and pump it straight into the cloud database as well. So there's a couple of different options there. We also have like some utility libraries that you can kind of massage and manipulate data if you want to kind of change the data format where it's coming from into Neo4j. And you can use things like Kettle and stuff like that if you're familiar with Kettle, which is a data, not integration tool, but it basically just passes data back and forth in various types of sources, data sources. You can use that as well if you're already using that in your business. So there's lots of different options out there for import. But if you want to kind of just start out with a project, I'd say either start with something like the ETL tool, or if you want to load it into Aura, there's a built-in importer tool there.
I don't know if you covered in that last. So is there something different between Aura DB and Neo4j DB?
Yeah, so AuraDB is our service, really, our cloud service, where Neo4j is kind of the database. But it's just, I mean, it's still the database. It's just running in the cloud, and we call that AuraDB. We also have a data science rendition of that. It's called AuraDS and so on. So names could get really confusing. But yeah, it's all the database. It's just kind of where it's running. Yeah, I do have a couple of stickers on the table too. If anybody's interested, you're welcome to snag them. I have gobs of them at home, so yeah, absolutely.
I was also curious to see how you actually loaded the data initially.
Yes, I'm happy to do that. So,
If you have time, I'm not.
yeah, absolutely. Yeah, technically, I think I have 5 more minutes in my presentation slot. So. So what I did, I have out on my GitHub, and I have all the links in the project repository. So this is the project repository I linked in my slides, and it'll tell you, here's how to create an Aura instance. Once it's created, then use this script in order to load the data into the database. So what I did is basically I have this graph demo data set repository that I dump lots of different data sets into, and I have this whole Java version and diff kind of data set, which is pulling from the Java Almanac GitHub repository, open source data. They have their own website that populates it, and you can play around with the different Java versions. But I've basically just taken their source code or their source data that's sitting down in here. So there's their diff files, and then there's all their version files. And I've basically just taken that, and there's a couple different options, but I use kind of the mainstream Java version import. And you can copy paste these into the browser here, and then just load the data. So all I've done here is I've just taken each of the versions and I unwind the data from the JSON files that are provided by the source and just populate those as nodes and relationships inside the database. So I could go through all the Cypher, but I won't bore or confuse anybody. But if you have questions about it, don't hesitate to ping me or say, hey, what are you doing when you do this? But yeah, you can literally just copy paste these statements and it'll load that data in for you exactly as I have it in my database. So, and I actually, the source data just updated a few things. Their date format changed. They had one date format on the GA date and one date format on the EOL date. They just fixed that and aligned it all, and I loaded my data, and I'm like, man, why does that look wrong? So I actually went in today and like updated and reloaded some stuff to kind of get the data look nicer. So they updated their source data. I try to keep this up to date as well so that everything looks aligned. So yeah, I just reloaded everything today and updated the script today so it's current. So yeah, and just loading all the sub-relationships and stuff here. So yeah, that gets you the whole graph, and then what you end up with is, if I look at my, basically this will show you the data model, the structure of the general data in the graph. I don't know why it doesn't like to, let's see, this is what I want here. It should show name. I don't know why it does that. I keep clicking that and it doesn't like it. But you get the Java version, and you get the source code link that it's managed by.
So say for example, you have has delta and then from. So that's something that you wrote in that code that you showed earlier.
Yes.
When you pulled in the data.
Yep. In fact, right. Well, you can see one example of it here. So the source code node here, I'm merging the Java version node, which I call J is the variable name here. Java version is managed by that source code node. So you can define the relationship. And when you either use merge or create, if it doesn't find the pattern already existing, it'll create that pattern for you. Because I'm using nodes that I've used before, it doesn't find the relationship, so it creates that new for me. And then I've set different relationship here, so a feature has a reference. In this case, here's my start Java version from newer version diff, and then a previous Java version to that same diff. So I'm mapping that whole pattern out, and yeah, you can create your custom relationship names if you want to. So yeah, then you get this really nice kind of fun thing, which is not super fun to read, but you get the version diffs, and then you have, of course, modules in the later Java versions and packages kind of all the way through. You have annotations, interfaces, classes is the next layer, and then one more layer down, you get the method and field names that are differences between the two. So you kind of have this, from the Java version itself and looking at the version diff, you have potentially 1, 2, 3, 4 hops or levels deep that you could go and look at all the changes that have gone on between Java versions. So really neat data set. I think a colleague of mine pointed me to this one, and I'm like, oh, this is really cool, actually really complex and deep and kind of fun to explore, so, and relatable to Java developers. So yeah. And again, not that this couldn't be done in other database stores, but really highlights kind of the strengths of what Graph can give you pretty easily. So.
Saw some security talks about dependency management.
Mm-hmm.
So yeah, in the end, they're all going to be doing graph analysis.
Yeah, a lot of it. In fact, there's some tools out there. I'm looking at one right now that it's called JQ Assistant, and it basically will analyze projects, and you can have it analyze dependencies, and it uses Neo4j on the back end and populates all that stuff for your project into Neo4j, and then you can analyze, okay, what's missing, what are some warnings, what are some things that are out of sync, and all of that, and it uses a graph on the back end to do that. So,
what if your project in like your CI/CD pipeline did a build and then calculated the degree of your dependency graph, so you can see when people are introducing more methods less.
Yeah, and problems and complexity and stuff. Yeah. Yeah, and for that you would use something, there's some built-in algorithms inside Cypher, but a lot of those are provided by our graph data science library. And we have degree centralities and all sorts of kind of community detection types of algorithms that you can analyze that kind of stuff with.
What's your background? Very fluid in the graph algorithms.
A little bit. I know a little bit. I know enough to be dangerous. Let me put it that way. No, actually, I worked for a financial investment firm as a Java developer, but I actually wrote a lot of SQL and SQL scripts, and they called it SQR, SQL reporting, and bash scripting and things like that. And I wrote some Java there, but not a ton. My schooling was Java focused. And then I switched and went to this and focused heavily on the Java, but got introduced to a lot of kind of graph technologies and more database things than I knew. I didn't even realize graph existed until I came to Neo4j. I was like, oh, why did nobody tell me about this? So I knew there was such a thing as MongoDB and document databases, but past that, I didn't really, just outside of relational. And so I kind of opened me up to graphs, and I had a really good colleague or two of mine that was really big into the algorithms. And it's really neat when you see somebody, the mathematical side is not my strong suit, but looking at it from a data understanding perspective and what you're learning and what you're able to see using those algorithms, it's really powerful and really interesting. So I learned kind of some of the theory and the general structure as applied to developers. I'm not a data scientist by any stretch, but just kind of those little bits and pieces is really cool to understand the network. So.
Yeah. I'm a fan.
Great. Glad to have you.
Last job I'm working for Gridgate now.
Okay.
Different NoSQL database.
Oh.
And they're the donor for the Apache Ignite project.
Okay.
So it's a distributed database execution engine, kind of disjoint from like the Neo4j
Okay.
space. But I was doing performance engineering for SAP Commerce.
Nice. That'd be interesting.
For like the last 5 years, and for a few clients, I actually whipped out like Neo4j to show them their object model,
Yeah.
to like demonstrate for them complexity problems that they had in their data.
Yeah. Yeah, Neo4j it's not a silver bullet, it doesn't solve every problem, but there's several use cases out there. It's like, that's not really suited to the other databases out there, and Graph fits that beautifully. So that's.
I put a few cases in the Neo4j database,
Yeah.
and run a Cypher query to explain what they're doing in their dev test, and like, here's what it looks like when we do it in prod.
Right.
The prod data you have, and here's the graph that
Yeah.
explodes out of that.
Yeah, it's really cool, really neat. So technology is really cool. So.
It's kind of sad. Like if you watch movies though, like graphs as an idea, when they present it, like there's always like the crackpot like psycho with like the bulletin board and the pins and like the yarn going between them.
Right. Yeah. I mean, it's a graph.
Yeah, as soon as they start depicting nodes and edges, it's like in popular media, it's an indication of insanity.
Yeah. Well, yeah.
All right, thank you.
Yeah. Thank you guys for staying.